Last time we were doing basis, yeah. So now, what are we on to? We did base. Yeah. Let's roll. Okay. No one else downstairs with you? Actually, this lesson is pretty easy. It's the next two lessons are pretty easy. It just gets a bit harder after that. So for this lesson, we're just looking at calculating magnitude. So let's do a couple of examples. They're really quite good. So magnitude and direction. I gave you the formula last time for magnitude, so let's have a look at an example. So here is vector A. Let's say it's 3, 1, 2, and then let's say here is vector B, and let's say that's, I don't know, 1, 2, 2. I want you to, just for warm up, I want you to calculate this, and I want you to calculate this. So, just to get started, if you could calculate those. You remember the formula? Using Pythagoras formula? You know the formula?
Tan inverse y.
No, that's for angle. He knows it.
C squared equals A squared plus
Kind of. Not really. Nearly. You got the first one?
root 14.
Yeah, it's root 9 plus 1 plus 4, which is root 14. Who's that? Me or Adnan? Adnan. Come on, Adnan, you live on campus. Why are you so late? You were looking for what? B is square root 1 plus 4 plus 4, which is square root 9, which is 3. So there are the two lengths. The length of A is root 14 and the length of B is 3 units. I know it's not the scale. You got that? That's okay so far? Now, what's interesting is if I asked you, well, what's the length from A to B? So if you want to know the length from A to B, that's like me asking you what's the length of the vector, the Euclidean vector AB. Well, you don't have the AB. You don't have this vector, do you? But you have a very simple triangle law that can let you find AB. What is it?
A plus B.
No. B minus A. So that's the magnitude of the vector B minus A. So 1 minus 3, minus 2. 2 minus 1, 1. 2 minus 2, 0. So this is square root 4 plus 1 plus 0, which is square root 5. So the length of the vector from A to B, in other words, the length of AB is root 5 units. So by using this simple formula and by using the magnitude formula, you can work out the distance between points in three-dimensional space. So this would be a typical sort of exam question, you know, part A of a question would be calculating, they'd give you the A and B and ask you to calculate the length from A to B using vectors. So if we can write this down and we'll have a look at some other questions.
So this is the magnitude.
What's the magnitude?
AB.
Yeah. This, I'm sorry, did you not know this word? Because we didn't, you know this word or you don't know it?
Yeah.
Okay. Because you should know it. Oh, projector. Yeah? Got that? Okay. Let's have a look at something else now. So, that one wasn't too bad. Yeah, this lesson actually is quite easy. It's just really the magnitude formula. But another concept, which I'm not sure if I've talked to you about it yet, something called a unit vector. Now, is this something I've done with you, or is this something you know, unit vector? If you see it. So, imagine you have this vector here. Mir, why are you so late?
So much traffic.
But then that just means you have to leave 20 minutes sooner, because this was the same problem last time.
9 I came from my house.
No, not 9:30.
9:30.
No, not 9:30, because look what time it is now.
8:30.
Yeah, that's quite different to 9:30. 8:30 is too late. It's too late. You need to...
Traffic.
I know, so leave at 8.
Come by walking.
Yeah, you're in that mind, yeah.
Yeah.
So what are you doing driving?
Much easier.
Oh, I know it's much easier, but it gets you in much late. Anyways. 3i, yes, no?
Yes.
No?
Yes.
No, you stay there. This is your punishment. 3i plus 4j. So we want to make a vector that points in the same direction as the original vector, which I call x. And the only difference is its length is 1 unit. So I'll call it x with a hat. So I want this vector to have a length of 1. So any ideas on how I could do that? Well, firstly, let me just say that the length of x, what's that?
3i plus 4j.
The length, the magnitude of it? You can work it out. If you've got calculators, you can work it out.
How so?
Pythagoras. square root formula we just used.
3 and 4.
Yeah.
Okay, where's I and where's A? Above?
That doesn't matter.
Okay, no, I thought this was, okay.
Yeah.
Yeah,
5,
5.
yeah. Square root, yes, exactly. Square root 9 plus 16. It's 5 units long. So this is 5 units long, and we want this one to be 1 unit long. So how could we shrink it down to the right size?
5 minus, yeah, well.
Yeah? What do you think?
3 and 4 minus 5.
No. How do you make a vector bigger or smaller?
Divided.
Just divide it by 5, and now you shrink it down to the right size. So basically, as a formula, the unit vector of x is the vector x divided by its magnitude, and this will shrink x down to 1 unit long. Okay, so there's an example there.
Can you tell me again what symbols mean?
Which one now? The hat means the vector of length 1. The arrow means it's the vector, and the vertical lines means it's the magnitude of the vector. Yes? Yeah. Okay, next one. So what I'm going to do now is I'm going to give you a vector. I'm going to tell you its angle here is, let's say, 40 degrees, and its magnitude here is 3 units long, and we'll call this vector x. And I want you to give me the I and j. The k is 0. It's in 2 dimensions here. 2 dimensions. So this is something you know how to do from physics. So I'll just give you a minute to try and think about it and give me the 2 parts. Yeah. This is physics. Where's your calculator? You have an answer? So let me just change the colours here. This side is 3 cos 40, yeah, and then this side here is 3 sine 40. What's 3 sine 40?
1.928.
1.928, and then the cos one? 2.298. Let's check that this is right, because if we calculate the magnitude of x, our answer should be 3 units. Yeah? Close enough? Yeah.
2.9999.
Close enough. Yeah, but of course we did this in physics. Yeah. Let's see what else we've got here. Yeah, that's really it. There's not much in this. Number 6 is the only one that's hard. 1 to 5 is very easy, I think, because they're just like what I just did. So I think what I'll do is I'll let you try 1 to 5, and then we'll do 6 together, and then after that we'll go on to the next lesson, which
Have
is...
1 hour only.
What?
Have 1 hour only.
What do you mean?
No.
The next hour is, I think.
No, we have 2 hours now
New concept.
for today.
Really? Okay.
Yeah, see, look how happy he is. Look how much joy I've brought to your life. So, I just want you to do these for a few minutes, and then we'll go on to the next topic. So, just try 1 to 5. Do I even want you to do each part in 1 to 5? No, just do the A parts in them, okay? Do you need me to open them back up? Yeah. It's a little bit blurry.
So we have 3 hours break after
Do you?
Yeah.
Good for you. Give you time to work on your maths assignment. What do you mean, no? Is it finished?
No, not yet.
3 hours will get a lot of it done.
But that,
I'd say in the 3 hours you probably should get task 1 and maybe 2 done.
really?
Because you're just using trapezoid and Simpson's rule. It doesn't take 3 hours to do that. Right?
The magnitude of A plus B, meaning I have to get the square root of all of them.
You add, oh, that's mistyped. You add A and B first. So like here, this is magnitude of A, get the answer. Magnitude of B, get the answer, add it together. But here, you add A and B first, then get the magnitude. So you're checking if the following are true or false. So one are you on, Iyad? So what was did you get true or false for the first one? False, yeah. So,
For the first,
yeah.
I got 161 and 160.
Yeah, so false. They're not equal, are they?
Yeah, but I think if you like add all the
No, the first one is not 160.
It's 161.5 and 14.07.
Right, it doesn't,
It doesn't matter.
yeah, did you get the same number on the left and the right?
No.
No, so this equation is a false equation. So my point is, in this question is, this is not true. The magnitude of A plus the magnitude of B is not equal to the magnitude of A plus B. This is not a formula. If you're wondering which ones are actually true, B is true. Magnitude of A plus magnitude of A is twice the magnitude of A. C is true. D is false. And E is true, if you're wondering. Might be worth writing down the true ones. So like I said, B, C, E are true. Am I still recording or did I stop the recording? That's still recording. Let me just save this video. I did this as an example, which you missed because you were late because you left your house late. Which one are you on now, Yes? Good.
What's the difference between 3 and 4?
No different, really.
Okay.
Yeah, just phrased differently.
Go to -6.
No, we're going to do 6 together when you're finished. So just one more minute, and then we're going to have a look at 6.
This is the formula.
Okay, let's have a look at 6. Okay. Can we have a look at 6 now? Yeah. The vector A equals 1 and 2. Oh, come on.
Because the dot
Yeah.
is it before you put the pen on the...
No, the dot's there wherever you leave it, and then move it. A equals 1, 2, and B equals 3, 4. and C equals lambda A plus mu B. Part A, simplify this. Okay, well that'll be lambda 1, 2 plus mu 3, 4. That'll be lambda 2 lambda plus 3 mu 4 mu. That will be lambda plus 3 mu 2 lambda plus 4 mu. So that's the first part. Are you writing this? Right. Okay, got that? Part B now. What is the magnitude of C? Okay. So part B, the magnitude of C will be square root lambda plus 3 mu squared plus 2 lambda plus 4 mu squared. It will be a bit of a pain, but let's go for it. Lambda squared plus 6 lambda mu plus 9 mu squared plus 4 lambda squared plus 16 lambda mu plus 16 mu squared, which is 5 lambda squared plus 22 lambda mu plus 25 mu squared. Okay. Yeah. Okay, C is what is the relationship between lambda and mu if C is a unit vector? Well, if C is a unit vector, that means its magnitude is 1, which means its magnitude squared is 1, which means 5 lambda squared plus 22 lambda mu plus 25 mu squared equals 1, yeah. D. What is the relationship between lambda and mu if C is parallel to AB? Okay, so just up the top for the moment, I need to work out what AB is. AB is B minus A, so that's 2, 2. So, I'm telling you that C is parallel to AB, which is 2, 2. So what happens is when vectors are parallel, like for example, if this vector and this vector are parallel, their relationship is that one vector should be some number multiplied by the other vector if they're parallel. The only difference is they're bigger or smaller. So if this is vector 2, 2, what I'm saying is C is parallel to 2, 2, which means that lambda plus 3 mu and 2 lambda plus 4 mu, that must equal some constant multiplied by 2, 2. which must equal something like 2k and 2k, like this. Which basically means that lambda plus 3 mu must equal 2 lambda plus 4 mu. Yeah, because this one must equal 2k and this one must equal 2k, so then they must be equal to each other. So you get lambda plus mu must equal 0. Yeah, must equal 0 then. Okay.
No.
Yeah, one sec. Lambda, find lambda and mu if C is a unit vector parallel to AB. Okay, so the last part here is it's parallel. It's parallel and a unit vector. Okay, well if it's parallel, we've just said lambda plus mu must equal 0. If it's a unit vector, we just said 5 lambda squared plus 22 lambda mu plus 25 mu squared must equal 1. So this equation here means lambda must equal minus mu. So we can put these together and you'll get 5 mu squared minus 22 mu squared plus 25 mu squared equals 1. So what's that? 8 mu squared? That's 3. No, yeah. 25 minus 2 is 3 plus 5 is 8. 8 mu squared equals 1. So mu equals plus or minus 1 over root 8, which means lambda equals minus or plus 1 over root 8. So that's the answer then for the last one. So I told you this one was hard. This would be like a section B question in the exam. Can I close this?
It's 1 hour now. Our time.
Yeah, but it's okay. I feel very kind today, so we can close it. The cold air is good for you. Wakes you up, makes you feel fresh and alive. No?
Sleeping.
Sleepy. Okay. Can I close this now? Iyad? Yeah. Yep. Okay.